Hello everyone, welcome back to the channel. Today we are diving with the topic that is what is bias and variance trade-off. Yesterday we have discussed about the all different type of the regression matrices. So the bias and variance trade-off is the biggest challenge for everyone. Either you have just started learning the machine learning, or you are at an intermediate level, or maybe you are working or professional too. Because this is the biggest challenge when we are building the model. Either our model goes overfitted, underfitting, or sometime it is come up with the high biasness and high variance too. So our goal is to reduce or balance the biasness and variance. So we can build the good model. Low variance, low biasness is a good fit model. High variance, low biasness, high biasness, low variance, high biasness is not good for your model health. This is the biggest challenge. So you are going to learn about it today. I am going to give you the most simplest example today. First, I will make you understand what is this, and then we will discuss it how you can reduce these kind of the errors like the bias and variance. And after like going through the layman examples, we will jump on to the practical example too. So stay with me till the end of the video. Keep watching, keep patience with Science Data Science. So let me open the next slide. Okay, so look at this. So here we have the machine learning errors. So now what is machine learning errors? Machine learning errors, this means we are talking about the model errors, right? You build any model, let's say you build the model here, house sale price, right? So this is your model. But it is creating these kind of error. Maybe your model is overfitted, underfitted, right? So it might, if these kind of the errors your model is producing, this is called reducible errors. Reducible errors means which you can control. Okay, but there are other kind of the errors also occur in your model which we cannot handle. This is not in our hand. Like when you are going to train your model using the data set, your model learn from the noise too, actually, which we can't control. That is called irreducible errors. And there are sometimes like the human like the labeling mistake too. Whenever you are fetching the data from some server or the places, or there is a data set, right, which is coming up with the maybe misspelling, right, in the label, that is a irreducible error. We cannot control it. Okay, so now you know what kind of the errors your model can produce, right? We will move ahead now to the next slide. Before moving ahead in with the detail about the bias and variance trade-off, I would like to tell you the different scenarios your model might produce these kind of the errors, right? Look at this picture. So this is the student, right? So he is trying to solve the question actually. He is saying 2 plus 2 and he is thinking it's a 3. Okay, so this means let's name it with the Alice. So what does the Alice does? Alice like misunderstood the concept actually. Alice misunderstood the concepts. Okay, he did not try to learn the actually in detail. He just read the top level concept. Read the top level concepts. So what will happen in that case? He will not be able to answer, right? So because what he does, he has just like learn about the top level concepts. But when he was doing okay and good on the training data, okay, okay. And then on the unseen data, he's also doing okay, and this is also okay. Why? Because he just understood the top level of the concepts. He did not did not go into the detail. So whenever he is solving this question, he is getting confused. What is the output of 2 plus 2? So that is called high biasness. So who is Alice? Alice is the model. So when your model is not able to learn properly during the training, and it is also not predicting the data on the unseen data, when we are providing the unseen data, that is called high biasness. We call it underfitting too. So your model is not working on training data properly, and it is not working properly on the test data too. If you can consider it according to your exam too, I will show you in the next slide that example too. Okay. So this is called the one like the case of your bias and variance. In this case, your biasness is high and this is low variance. Okay. Now we will talk about this scenario. So in this case, Alice learned about the detail too. He learned so much, right? He understood the all training part very properly. Okay. He is very good. He got a 100% marks during his training. But when we provide them the test questions, so he did not perform well. Why? Because we tweak the some questions. Questions were from the training data, but we have twisted the questions. And Alice is not able to understood the questions. Why? Because he is focused too much in the detail, the same to same question, and he is expecting the same type of the question with the same wording in the final exam too, in the test too. So in that case, he won't be able to clear or properly answer the test question, or you can consider it test data too. So he is still confused. So in this case we call it model is overfitted. So this means you are able to do good in during the training, but you are fail in the test exam. Why? Because you just focused on the the curriculum or the question and answer which I provide. If you consider me as your instructor, which I provide you only during the training, right? You focused only on those. You did not try to understand the about the detail of the topic, right? Now, look at this scenario. Low bias, low variance. This is what we always want. So this means you answered all questions during training. Okay. And also during test exam too. Excellent. So this is what we want. Okay. So you understood the concepts too and the details too, both. If even I am tweaking the question, you will be able to answer. So this is what we want. This is a good model, best model. But in case this is the high biasness, high variance, this is the worst case scenario. Worst scenario. Okay. So it is going to produce the errors during the test data because it is not able to predict it correctly. But it is also doing good on the training too. But there is a high biasness too during the testing. Okay. So this we never want for our model. This means your model does not learn not even during the training, not even during the your testing. He is totally fail. So this is the fourth case. We never want these three cases. If you have a high biasness, we can increase it to balance the variance. And if it is a high variance, we can reduce the variance, increase a little bit biasness. And in this case, our model is dumb model. We have to control both, right? So this is a perfect model. So these are the four scenarios I wanted to share with you before we move ahead with the your bias variance trade-off. Now I will separate them with the very good more example using this same student analogy, right? So let's move ahead. Okay. So now I have already told you what is bias and variance trade-off. Why we call it trade-off? Because if a bias is increasing, your variance is decreasing. And if a variance is increasing, your biasness is decreasing. So it is just trade-off, right? Everything. I will show you the in the graph too. So that's why we call it a bias variance trade-off. So this is the same example which I have already shared with you. Okay. So what is the moral of the story? We need a student who can learn smartly, not just doing the hard work. And we are aiming for that sweet spot between overfitting and underfitting, right? We want the this model, right? Low variance, low biasness. This is we want, right? No overfitting and no underfitting. This is what we want. Right? So this is the just a definition of the bias and variance. Okay. So I have already given you the example, right? Now we will talk about it in a more detail. Look at this. What is a high variance? As I told you in the first slide, high variance means overfitting. Let's take a same example again, but I will visualize it too, like on this graph. So it will make more sense to you now. So here I will make it little down. Look at this. So the Alice has this study approach one. Okay. What the Alice is doing? Alice is memorizing the every tiny detail. Okay. If I have given the 10 question and answer to the Alice, he is like looking at a very deep level and trying to learn the or cram the question answer even the one word from the question and answer. This is what he is trying to do. This is the first study approach of the Alice. So it is like a model with the high variance. So what will happen in this case? Alice will be nail the training data because it remembers everything perfectly, right? So this means what questions I have given to the Alice, he will be able to solve it, right? But the moment the questions change even a little, let's say in the like the test, I have given the question right to the Alice, what is machine learning, right? So he just memorized this question, okay? He memorized the question with the answer as it is. But in the test, I asked him the question, what are a different type of machine learning, right? If I am answering here, I am also explaining in the answer types of the machine learning under this, but here I have tweaked the question. I asked him directly what are the different type of the machine learning. Although he has already read about in this question, but he is expecting this same question in the test too. But he is not able to answer this question, so he got failed, right? So his performance will drop during the test exam. Same with the model. When you are giving the data to the model, model has learned all like the feature and their relationship with the target and the patterns and memorize it at a very deeper level. Might be you are applying the complex model, right? In that case, what will happen? Your model will give you the, during the training, your model will give you the 90% accuracy, 95% accuracy. You will be happy. But when you give the unseen data to the, like the model again, right? So there is a little bit changes in the value of your features, right? On what your model has trained, but your model will not be able to understand those. Why? Because your model has memorized everything at a deeper level. Now your model will not understand if we are tweaking the questions little bit. So that's why this scenario is called high variance. and we call it overfitting. Okay, so this is the same. Now look at this. This is your actual value. This is the predicted value. Now you can see the red line is your predicted value, right? And you just look at this. During the training, your model is fitted on it very like it memorizes everything, right? So this is the training. Okay, so this is called overfitting. Your model has learned so much. Whatever it is learning, it is saying yes, this is the value, right? So it is fitting onto the your data points like this. This is called high variance. Your model has learned too much. It memorizes everything like the values, patterns, relationship from the training. But its performance is going to be dropped when you even little bit changing in your values of the feature. Even you add the new feature, your model is going to fail. It will not be able to build up the relationship. Okay. As I had given you this question example. Okay, so it is struggles to generalize to the new unseen data. So this study approach is going to be failed. Okay, so now I will give you another example about the your high biasness. Okay, so what is a high biasness? Look at this. This is the underfitting. So in this case, now Alice is following the study approach too. What the Alice is doing now. Previously, he was cramming the each question and answer in a detail. But here, it is only focused on the big ideas. Skip the detail. He is only understanding what is machine learning, but it is not trying to understand different type of the machine learning actually, which is written over there. Okay, so it is like a model with the high biasness. What will happen now with the Alice? It is Alice will struggle on the study guide because it did not learn enough, right? Might be during the training there are like the questions as well, but it is still struggling because it is just working on the big ideas, right? And it does not do well on the unseen data too. Unseen means test data too, like the test exam too. Okay, so this is a situation when if we connect it with the model, when you give the data to the model, your model did not try to understand the full pattern or relationship of the independent features with the target correctly. It is just focusing on the big ideas like these are the features, these are the values. It is not going learning each and every pattern. It is just focusing on the big ideas, your model, and it will not give you the good accuracy even on the training. And when you give the test data to this kind of the model, it is also going to fail. So your model is not working on the training, it is going to fail. No, and on the test too. This happened in case of high biasness, and we call it underfitting. Okay, so this means your model did not learn, or maybe your model did not get the enough data so it can understand the patterns, right? And the relationship between the independent and the dependent feature. That's why it is not able to give you the good predictions for the unseen data. It happens mainly in case when you have the sometimes very simple data set. Number two, you have a less data, right? If you are giving only the, let's say, 100 records to your model, right? And you are trying to, your model learn with these records, it is not possible. Okay, you need a many values. Okay, I'm just giving you the example, this just the 100 records, it can be any numbers. So your that data is not enough for your model actually. Your model need more data to understand the pattern, right? Like if I give you, connect it with you are not able to understand the topic at a deeper level with if I'm giving you the 10 question answer. You need a more question answer for the practice. So if I give you the 30 question answer with the more topics, more details, then only you will be able to learn it. Same with the model. And this scenario is called underfitting. Now look at this graph. So this is your actual value. This is your predicted, right? This is your line predicted. It is not even working good on the training data, right? And this is not working. This is the predicted data. It is not working good, right? So your model, your trend line is not fitted properly onto the data points, right? And your all the predicted value is not close to your actual value. So your model is failed. Okay, so this is called underfitting. Your model will look like this. It is not able to build up any relationship. That's why your trend line is straight. But if you go back here, your model was, it is, but it was still able to make a relationship during training, right? It understood. In this case, what you have done, you have given the so much data to the model. So your model built the strong relationship. Like for example, instead of 10 question answer, I am giving you the 40 question and answer, and you just get masters in those, right? But what will happen? You will get, you are going word to word detail in the question answer, right? And if I'm tweaking the question, you will fail. Same with the model. So model has learned so much, it might be learned from the noise too. Okay, so this is the way how you should understand about the underfitting and your overfitting. Just think about it. When we are talking about the overfitting, this means there is a high variance. Your model is only working good with the training. It is going to not going to work with the unseen data. When we are talking about the underfitting, there is a high biasness. This means your model is not going to work with the training and not going to work with the test data, because your model is not getting enough information so it can understand the relationship or patterns of the independent feature with the target one or dependent feature. Okay. I hope if you still have a question, you can drop a comment. Now, this is we want. This is I want my every student should be like this. Okay, low biasness, low variance. So this is not a straight line, right? It is just going in this form, right? So it's actual value. This is a predicted one, but it is trying to fit, but some data points here too, right? So there is a no high variance, because if this is the case of high variance, then it will be like this, right? And if it is a low biasness, high biasness, sorry, it will be like this. We don't want this. We want something result like this. Okay. So this is we want. So this is about like your high variance and uh, high variance and high biasness. Now, this the graph which you are looking at right now, you will oftenly see this graph. You might have drawn this graph too when you are just checking the total errors in your model. This is going to be your best friend. Actually, you should draw always this graph when you are working with your uh, model. Okay, it will clearly show you. There are other ways too, as I have showed you previously. You can draw the graph like that one too. I will show you those graphs in my practical example. Okay, now look at this. Just try to understand and listen it very carefully. On the x-axis, we have drawn the model complexity, and this is the error. Okay, and look at this on the left side. This is underfit, this is overfit. Okay, the red line is of the biasness and the blue line is of the variance. Okay, and the black line is of the total error. Now look at this. If the complexity of the model is increasing, right, your error is increasing too, right? Your error is increasing too in this case. Okay, so here what you need to do, if here if we are trying to decrease the, here look at this, if the bias is decreasing, right, your variance is increasing. So that's why it's very tough to balance both of them. We need to do a lot of hard work, right? We need to do a lot of hard work in this case. So if the bias is decreasing, variance is increasing, your model is going overfitted. Okay. And what will in what scenario this will happen? When your model is too complex, like if you are applying the random forest, you are applying the decision tree, you are applying the XGBoost, you are applying the SVM, neural network, right? These are the complex model. Okay. And random forest is the most oftenly known algorithm for the overfitting, because we are training the model at each and every level, because it is creating the many trees, right? It is like looking at the each and every value of your like the given in the features. I will show you in the practical example. Okay. That's why its variance is increased. When you are applying the random forest, definitely your model going to be overfitted. You have to take it. Sorry, this thing. Okay. Now look at this, error will also increase. Why? Because your variance is increasing, right? Now if we consider the opposite case, look at this. If your model is too simple, up to this level your model is simple, so variance is low. But if your model is too simple, your biasness is increasing. Biasness is increasing, right? So this is the biggest challenge. That's why I was saying you this is the biggest challenge, right? So your model is going to be underfit. It will also increase error. What kind of error? Biasness, right? So what is a sweet spot? This one. So this is the balanced one where optimum model complexity. You can see here there is a less error, right? Error can be till here, and your bias is controlled, and your variance is also controlled. Sorry, this is you need to build. Okay. So this is going to be your best friend. At this point, your model should be. So this is the best graph to make you understand about the your bias and variance trade-off actually. Okay. So if you draw this graph on your notebook and then try to understand, and you can draw with your model performance too. I will show you in that one, not exactly this, but the over other graphs, right? When we are trying to predict over actual value and the predicted value. So it will show you the your error value over your train and test too. Okay. Because what is variance? Variance is your test training data. Right? That's why it is overfitted. If your training accuracy is high, that is means high variance, right? But what is this? Biasness is your test data, right? So this means your this is not working correctly on that, right? That's why like your model is not working on the test data correctly and training, then your model is underfitting. If it is only working good on the like the training data, not good working on the test data, there is a huge difference in the accuracy value between the training and test, then your model is overfitting. Okay. So I know at a beginner level, it's a little bit tough. Okay. But still, if you have any confusion, you can drop a comment. Okay. So this was the about like over like the bias and variance trade-off. Now we will just assume at this value. Look at this. So I am considering the R2 score. If you don't know what is R2 score, you can watch my yesterday's video. I have explained it in a detail. What is R2 score? This like the uh, your accuracy. It is not accuracy actually. This is a regression metric. We use it to check the variance of data actually, how well your model is performing, how well your model understood the independent features, which is helping to predict your target feature. So if you look at the first value, your model is not working good on the train data and test data, because training accuracy is 27 and this is 25. So this is high biasness underfitting. And this is 95/57. This means your model is working good on the training data, but fail on the test data. This is called high variance overfitting. We don't want these situations. We need to handle in these situations. This is a good fit because there is a less difference between your training and your test. So this means your model performs well during training too and here too. Okay, so this is a good fit. This is just the layman example. Okay. Okay, so how you are going to solve the high biasness and high variance? If your model is high biased, this means we need to try the complex model. Why? Because, for example, if you have the house sale price data set, I will give you this example. Or we can consider the churn customer, right? Churn. So here there is a one field, we can take it education. Okay, it can be any feature. I'm just taking the dummy level. Okay, so this is a PhD, this is the diploma, and this is bachelor 101. Okay, so you want to predict whether the customer will churn or not. Okay, it can be the income column too. I'm just assuming it. Okay, so if I'm applying here the linear regression, right? My model might not be able to understand it. So it will create the high biasness because my model would not understand the relationship too much, right? Or maybe I have a less data, right? It can be any reason. So in that case, it is going to be high biasness. So I will apply the complex model now. Which model? XG boost or maybe random forest. So these are the complex model. So this is you need to do in this case. And I will train for a longer time period because when I will apply the random forest instead of linear regression, it is going to into too much detail because it is going to create at every condition, it is going to create the one tree, right? And check yes or no. And then again, it will continue that depth of the tree till it won't satisfy the result. But in this case, this is not possible. So that's why there is a high biasness. Okay. So whenever your model come up with the high biasness, try with the complex model. If it does not work, then might be you need to add a more data too because you have a very less data in that case. Okay. And so there are different scenarios I don't want to share right now because in that case you will get confused. Okay. So here the high variance. If your data if your model has a high variance, then you should apply regularization method. Okay, regularization method because we cannot reduce the data set and we cannot go with the more complex model in this case, right? Because we have already applied. If you are thinking to I will apply the simple model, this is not possible too because otherwise your model will go high biased. So in this case you need to use a regularization method. Okay, I will tell you this practically too and now too. So just let's move on. Before moving ahead, look at this picture now. Just drop a comment out of this. Which image is a good fit? Which image is the overfitting? And which image is over of the overfitting? Okay, just drop a comment by looking at this question. If you are dropping a comment and watching this video, much appreciated, right? It will also help me if like you understood what I am discussing with you. Okay, your feedback is also much appreciated. Okay, so maxima, so what did you understand now till so far about the high biasness and the high biasness, high variance? When we train the model, definitely we want the accuracy on the model too, right? During the training, that's why we will get understood like our model has learned or not, right? But our goal is to maximize the testing matrices, right? Because tomorrow when we are going to deploy our model, we want our model should predict the correct value on the unseen data, which is our goal, right? So now, so we cannot like compromise in case of the like to test performance just to reduce the variance. Okay, so this is very important. Now, this is a regularization method. I will show you practically what is regularization method. Okay. So we need to apply the right level of the regularization method to achieve a balance between bias and variance. Okay. And the goal is to fine tune the regularization to strike the right balance between the underfitting and overfitting. There are many methods come under the regularization. If today I am going to show the few of them, okay, but definitely to make it in a detailed video, I will definitely make a detailed video too on this regularization, okay. And then look at this. When you apply the regularization method on the high variance data, your model will become like this. This is the biggest advantage. Okay, so regularization help a model to avoid memorizing the training data, right? Like for example, if I am asking you to just understand the concept, which I always used to say in my every video, don't memorize anything, just try to understand the process. Don't memorize the code. Try to understand the logic. This is same we are going to do this here. Okay, we want the model to understood the like the pattern relationship between the independent and dependent feature. We don't want the model to memorize the things. Same with you, okay. And it improves the generalization by introducing the penalty of the complexity, trading a bit of bias to reduce the variance. Okay, penalty means it will add the penalty during the your when assigning the weight to the model actually. Okay, it is called lasso and reach. I have explained it in my regression models desktop. You can watch that. Okay, all right. So now let me open here over notebook. So this one, just give me 1 second. So here we go. Let me share the screen. Okay, so this is our coding notebook. Okay, I have picked up the data set of KC house pricing. This house containing 21 columns and this much rows. Okay, this much records we have. Here I have written the data dictionary. You should read the data dictionary always before you going to start work with your machine learning model and your data analysis. This is very important. Okay, and then here are the features, right? And you can read about the features, what the each feature like the meaning of the each feature. Here we will import the important libraries. I have imported the dummy regression too. Yesterday I have already explained it. Dummy regression is your baseline model. Instead of before applying the complex model, because complex model takes time to train the model, you can just apply the baseline model. It will give you the benchmark of the your error, like the target average. Okay, predictive like the predictive average, your benchmark, like how your model is going to react with the features, how your model is going to give you the training or test accuracy. It is not 100% accurate, but it will just set some benchmark. You will get some idea instead of like you are, because when you are going to apply the random forest, if you're setting the maximum depth, let's say 10 or 20, right, your model will run at least might be minimum 10 minutes or maybe more than that, right? If it's a million of records, it is going to be run too much. So before applying those kind of the model, baseline model is your best friend. How? I will show you again today. So here we are just making the custom function to apply the calculate the mean absolute error, mean squared error, and your RMSE. If you don't know what is this, you need to watch my previous video. Okay. And here we have import the data in this. Look at this. So what is the goal of this one? So just read the goal first. To predict the house prices by creating a model. Okay, this is the goal. And then this is going to be your target column, right? All other are your independent features. Now this data set contains 21 column. You can also apply the feature selection method here too, which I have already built the video. You can apply the feature selection method here too. Okay. Here we will apply the info method. In this, we are looking at it the different your how many records you have, how many columns you have, what are the different type of the columns you have. Okay. And then we are just checking the duplicates using the df.duplicated.sum. It will give you the count of the duplicate values. If you don't use the sum method, it will give you true, false, something like that. Where there is a duplicate, it will say true. It is not going to show you the count. So that's why we are applying the dot sum method here. So it is showing us the 5 duplicates. We will drop them. As I always told you, there is a no use to keep the duplicates. It is not going to contribute in your model performance actually. So in place is equals to true means I am just making a changes in my original data set. Okay, but you need to make a copy. I'm not making the copy here, but you should make copy. Okay, and then we are just checking no duplicates. Now here we have a one variable in your data set, that is the zip code. At a beginner level, I told you this is the most common problem actually. Whenever you are at a beginner level, you find the zip code, right? You got confused. What is the data type of this one? Because this contains the numbers and alphanumeric or the alphabets too. Sometimes it can be numbers too, right? So if we go back here, look at this. So where is your zip code here? So it is showing me integer. But when we look at here, zip code is this one, right? But we cannot consider the zip code as an integer. Why? What is the reason? Why we can't consider the zip code as an integer? Because this is not, we are not going, with your model is not going to treat it as an integer. It should not treat the zip code as an integer. Otherwise, it will try to give the more weightage to the big number of the zip code. Look at this. It's a 98178 and it's a 98074. So if we are keeping it as an integer, your model will thought this is a higher number. So I will give the more like the weightage to this one. So it will try to make the relationship with it, which is wrong, right? Your model might become biased in this case. So we will convert it into the object. That's why. Okay. This is very important and keep this logic in your mind. Okay. Why we are converting it. This is the logic. Okay. Now look at this here. So we will convert it into the object and then we are just simply, I'm not doing here anything else because my goal is to today you to show you the variance and biasness. I'm not doing the deep level analysis here. Okay. So here we will split it. We will drop the target feature from it and keep the target in the XY. And then we are using the train test split and then create the X train, X test, Y train, Y test, right? These are the we are creating so we can train the model. If you want to learn about the actually your column transformer and pipeline, you can watch my video. I have already built the video on this in detail. Okay. Here, we will separate the categorical or numerical column by using simply make column selector. Okay. This is the inbuilt library. You can select it using this one. So I have imported it here. Okay. You can use this one too. You can use the selected data type too. Both are correct. Okay. And then we will convert the over your categorical variable into numerical using the one hot encoder. Sparse underscore output is equals to false because your data is going to be too dense, so we avoid them. If we are making it true, it will create the like the last column along with the other columns too. One in the one hot encoder. I have explained it in my previous video. You need to watch that playlist. Okay. And handle underscore unknown is equals to ignore. It will ignore those errors where it is not able to recognize sometime category. Okay. So it will not throw any kind of error. That's why we pass it this parameter. Now look at this. We are making the tuple. If you want to understand this column transformer, please watch my that video. Okay. So here we are just creating the two processing steps for your categorical data. First, we are converting it into one hot encoder, and then we are scaling the data too. Okay. Remainder is equals to scaling the data. And then here we are just trying to get the features out name. This is we use when we want to, because when you convert your data, categorical data into one hot encoder, it will create so many columns. Okay. It will create so many columns. Look at this zip code. Because here you don't have any other column object. You only have the zip code. And we are applying the onto this zip code one hot encoder. It will create so much columns here. Okay. So if you are a beginner, you don't understand what it is doing. Okay, I will give you the very small example. Look at this. So this is your zip code. Let's say it's a 9, 8, 3, 8. I'm considering two digit zip code, but you can assume this one. Okay. So let's say you have this zip code. When I applied it, the one hot encoder on that, what it will do? It will keep this field, original one, and it will create the two columns here. One for 98 and one for 38. Okay. So here when 98 is true, it will say 1, it is 0. And it is your 0, and this is going to be 1. This is one hot encoder. And at the last, it will create one column which does not contain any, like the default, all 0. Okay. So this is we don't want to create. That's why we are saying this one sparse is equals to false. Okay. So this is a work of your one hot encoder. That's why it is creating so many columns. Now we are just trying to get the features name. That's why it is showing, because we have applied this one. So it is showing one hot encoder underscore zip code this one. If you want to consider it, it's okay. If you don't want to consider it, we are just looking at it. Okay. And now we are just removing the final calls this line, this one. So I am just picking up the zip code with this one. So that's why I am applying it. So it is picking up the last this one and removing this portion. Okay. So it is showing this. Now the final call will be like this. Look at this. It has removed the one hot encoder prefix from your zip code. This method. -1 means picking up from the last. Okay. And then we will apply first baseline model. See now. So what is the biggest like the advantage? I am using the mean strategy. Okay. It will set the benchmark for the target column up to what level it is going to predict, the like the accuracy. Okay. So here you will just say dummy is equals to dummy regression strategy mean. We will make the pipeline fit onto the model. Now look at the accuracy. MAE is showing this one. This is a higher, and this is MSCE. This is double because it is not in the same unit. If you want to understand the difference, you again need to go back and watch my previous video, because this MSCE is not in the same unit of your original data. Okay. And then RMSE, this is the square root of this one, and this is R2. Now R2 0 in the training and R2 on the testing is negative. This means your model won't be able to understand anything, right? And it is not doing good. It is fail with the baseline model. Now you get just a little bit idea, right? Don't worry, your model is not going to fail, but it tell you if you are going to apply the simple model, let's say linear regression, it is not going to work out. It is telling you this thing. Okay. So it gave you the idea your model might be need a complex model. Okay. It is showing you here Look at this. This is the MSCE and this is the value of this one. And this is 358,730. And this is 392,293 this, right? So it is working okay or good on the testing, but it is not working here, right? So this is not good for our model. Okay. So in this case, what is the baseline model is telling you about your model is not going to work with the simple model. Now we will move ahead and I will show you the case of now high biasness. Okay, we are going to apply the complex method now, complex model, decision tree regression. Okay, so we will set the maximum depth here 1 now. I'm not going to take a too much depth. We will set maximum depth is equals to 1. And then we will fit on to the, here make the pipeline and then fit on to the X train, Y train. And we are calling it. Now look at the score. R2 is 32% and R2 for the test is 31%. So this means your model is not working at all during the training too and during the testing too. Why? Because over decision tree regression, we did not gave the high depth. We set it up to the one depth, which is very simple model again. So it is creating the high biasness. Okay. Because your model is not performing well during the training because it did not learn anything with the maximum depth one and it did not learn how it will perform good on the testing if it did not work on the training. Right. So this is model is underfitted, high biasness. Why? Because your model is too simple. This is you have seen in the slide, right? If your model is with the high biasness, what is the solution? You need to apply the more complex model. So this is we are going to do next. This is the one level. Look at this. Grade is less than equal to this. So sample point it pick up and this. Because your random forest model work based on the ensemble model, bagging and boosting. Okay. You can watch my previous video actually on that. Okay. So these are the result. It is nothing because right if I said the now I will show you if I am going to increase the depth, okay, then what will happen. Here I said maximum depth none. I said just now decision tree regression will run up to what level it want to run. We are not setting any maximum depth. Okay. So when it will run, I have already ran because it will take time. So I'm showing you the output. Now look at the result. Big difference. Look at this. Your model was able to understand everything. 100% R2. Highest the R2 value, best is the model. But look at this. It is 100%. This is 76%. Huge difference between the your R2 score and on the training and on the test. And even if you look at this MSCE or RMSE, we will look at the RMSCE 9027.97. Here it is showing this huge difference. So this means your model is overfitted. It is working great on the your training data, but it is not working good on the test data. Okay, so that's why your model is overfitted. So why this happened? Because your model is become now too complex. Now you can understand the situation when you are building the model, right? How do you feel, right? When you were trying to first setting the maximum depth so I can avoid the high variance or high biasness. What happened in that case? Your model goes underfitted. And when you try the complex model, your model goes with overfitted high variance. So this is the situation, right? It happened with every data scientist, even with the professionals. So that's why you need to think a lot. You need to understood the concept. I have made it like intentionally to show you the difference, what will happen in that case. Okay. Now, what is your duty? Your response is now to reduce the variance. Okay. So let's move on. Now we don't know up to what level your like a decision tree regression worked, right? What is the depth it has considered, because we don't know here by default, right? So you can get the depth very easily using the dot get method. Okay, on applying the your pipeline decision regression. So it ran up to the 37 depth. That's why your model learned each and everything. It just not learned, it memorized the thing. Now just try to remember that graph I was showing you, this one. This is the data point, right? And your model was fitted like this. Remember, right? So this is the data point. So now your model is in this shape actually. High variance. Okay. So we will clear this one. Now we will get the maximum depth. Why I am getting? Because so I can consider and assume and check the first score at what depth level my model was working good. At what like that depth level my model was like showing the score good for training and test both. Okay. Now look at this. So we will run the loop from the up to the 37 and we will print the score of each and every model at the specific depth. Okay. Look at the result now. Look at this. So this is the one. This is the depth level 1, 2, 3, 4. So it is going up to the your 37. Okay. So this is the final result you got, right? But here we need to find out which is the good one. Okay. I will tell you. So here how I have written it. I have just simply printed the your R2 score for each depth. This is I did. Okay. Here we are fitting on the train and model applying the, this is the same logic. Only we are evaluating using the R2 score and just printing the result. Okay. And now we will look at the graph now. Look at the graph. This is 37. If you now try to understand when your depth level was between 0 to 5, you can consider it 2. When your tree was at the maximum depth level 2, your model was not working good, right? It is like, look at this. So what is happening here? R2 score is very low. So this means your model is not able to understand anything. But if we are increasing the depth, look at this now, up to the 10. It seems to be okay, but if you increase more, it is again going up, right? And here. So we can consider the 11 or maybe 9. We need to look at it. But I am showing you graphically. The blue line presents the train data and test. And this is a R2 score. So I am considering the train and the difference between the train and test R2 score is less, is seems to be here for me. Because here you can see it is increasing very wide and it seems to be consistent, right? It's a huge difference. We don't want it because this is showing the high variance. We want the balanced one here, right? Now this is showing on the graph. This is the your like the graph which I was asking you to plot. Okay, this is your R2 score. And now look at this, how we will sort it in the ascending order. So when you sort it on the ascending order, it will show you the exact value of your depth level. This is 9. I am like sorting it based on the scores. Okay, what scores which we have got it from here by using this. Okay, so what is this? This is the creating the predicted, normally we predicted the values like this, and this is we are calculating the score, and then we are storing it into the specific location of this one. What is an depth level? Because we are passing here n, right? So it is a printing loop. We are using the loop here actually. Okay, so I will make you understand this code again. This is the depth. We will set the range for the what starting position 1 because depth level start from 1, right? And then vary underscore tree dot get depth plus 1 because it is starting from 1, so I need to do it plus 1. Okay, because the range always start with the 0, but we are setting the value 1. So there are a total depth is 37. So that's why you need to do the plus 1, 38. So it should run up to the 37. And then we are just creating the dummy data frame here scores. PD dot data frame train test index is equals to depth. So that's why at index it is showing the depth level. Okay. And here we are running the just for loop on n in depth. So what is depth? This one. What is n? Any variable. You can consider it any variable. And then we are setting the maximum depth, applying, make the pipeline, fitting onto the train data, your model, predicting the value, checking the R2 score, and then just printing it, assigning it, sorry, here. Okay, then it will print. This is how this loop is working. If you still need any clarification, you can drop a comment. Okay. And then we are just sorting it. First, we are looking at the graph. I wanted to show it you to graphically too because this is very useful. Okay. And then this is the 9. And here we are just making this one regression matrices and look the difference. I have fitted now my model, the decision tree regression. I'm not using, if I use the maximum depth one, my model was underfitting. When I use the complex model, I did not set any maximum depth, it goes overfitted. Now I find out this solution actually. Okay, so I found this one. So this is a parameter. This is called hypertuning now. This is the hypertuning regularization method, one of the regularization method. So you know the best depth 9. So you will fit on this. Now look the difference. Earlier it was showing the 100%. This was the 72%. Now it is still close to. It's a better than your previous model, right? So this is called regularization. But there are other methods too. Okay, but we are talking about today, sorry, the random forest. So we are hyper tuning it. Okay. And then you can, if you want to create the range from 1 to 20, then you can try this method too. And now if we look at this, this is showing this result and this is a graph. This looks more better than the 37, right? So here we can consider, look at this. This seems to be fine to me this here or maybe till here. See, less difference, right? So error is R2 score is increasing. If you want the R above 90, then you can consider here. But if you find the best one, so it is showing you 17. So where is the 17 here? Okay. So now we will fit the 17. Now look at the difference. R2 score on training is this. This is increasing. So you can improve it like this way. This is all regularization method. Only the thing is you need to understand the logic what I have done. First, we have just apply the dummy regression. We are just set the benchmark and it give us the idea what will be the R2 score on your data set if you are applying this simple your model. It give you the idea. Then I apply the maximum depth, which create the high biasness, underfitting cross. And then what we did, we apply the complex model to increase the biasness, right? Sorry, decrease the biasness, increase the variance. So in that case, our model goes overfitted. And then we need to reduce the variance, right? By applying the different your depth level. But how I have chosen the depth, you now know very well. Okay. If you still have any question, feel free to ask me. Drop a comment and keep learning, keep patience, and happy AI coding. If you are new to my channel, don't forget to subscribe my channel. If you like the video, please hit the like button and bell icon button so you don't miss any important video. Okay, I'm happy to help if you are facing any problem in any topic, either it's a data visualization, machine learning, or Python. I will definitely help you. So drop a comment. Okay, thank you so much for watching this video. See you in the next video.